K-nearest neighbor classification. Let's say we have two classes. We have the blue class and say a red class. And we're trying to predict this point here. Is this blue or is it red? So with K nearest neighbor, let's say K is 3. We look at the 3 nearest neighbor, and whatever the majority is, that's what we classify it as. So in this case, the 3 nearest neighbor is this, this, and this. So there are 2 blues, 1 red. We will classify this as blue. So for question, how do we choose K? Some things to keep in mind is, let's say, metrics such as precision recall and cross-validation. So if you choose a K that's too small, you may actually overfit because you're looking at a very, very small space. Whereas if you choose a K that's too wide, you actually start losing the subtlety of more localized patterns. Again, precision recall and cross-validation will help, and we'll cover those topics in different videos. As an extra topic, there's also something known as K nearest neighbor regression. And this is where, in our case, let's say K is 3, and you can take the average of 3 nearest neighbors for continuous variables. Let's say continuous outcome. So with K nearest neighbor, this was essentially trying to predict whether it is blue versus red, which is a categorical outcome. K nearest neighbor regression is trying to predict a continuous outcome. And here you can take a separate average. There's also methods where you can take a weighted average depending on which is closer and which is farther, for example.